Good morning, gentlemen. Again, I'm going to make a video presentation about loading of cargo with the use of percentage and what we call the percentage and what you call this one percentage and by proportionally when you load each cargo hold proportionally. Okay, so let's start, guys. This is now the problem, or example 5.13. MB Max Panama, which is 7 holds, is to load 66,588 metric tons of potassium sulfate, which storage factor is 0.9 cubic meter per metric tons. Determine how much cargo goes into each hold if the cargo is divided proportionally. Meaning, at this juncture, at this point, we're not going to use the stowage factor. We just fill the cargo hold by percentage. Okay, so here we fill by percentage, and here's the formula: share of hold capacity over total hold capacity. What is the percentage of hold? So we're going to look for the percentage for each hold in order to load the cargo. So hold capacity, this is the hold capacity per 1, 2, 3, 4, 5, 6, 7 holds. So where can we find this hold capacity? So we can find that in the capacity table, which is this one. So MB Panama Max Panama capacity tables. So in hold number 1, you have the capacity here. This is the cubic meter. For the hold, you have this figure. For the hatchway, you have this figure, the total capacity for your hold number 1, which is the sum, which is 9081.11, which is this one. 90811.11. Okay, then we go to number 2. Number 2, the total capacity of cubic meter is 12891.56. Okay, so number 2 is 12891.56. Okay, then we go to number 3. Which is the sum, which is 12831.48. Okay, 12831.48. Number 3 is 12831.48, and so forth and so on. Okay, so we just make your solution with this format. You put here the hold capacity of each hold, then over of the hold total hold capacity. Where can I find this total hold capacity? It's just under. So here, total hold, the sum is 82,025.08 metric tons, or cubic meters. I'm sorry, cubic meters. So this is the total hold capacity. So it is 82,025.08, which is this one, guys. So if you have already the hold capacity for each hold, you divide it with the total hold capacity of 820225.08. When you get the results, you multiply it by 100. That will be the percentage for each hold. Okay, so in hold number 1, the hold capacity of number 1, you divide it by the total hold capacity and multiply it by 100. That will 1 will be 11.07%, and number 2 will be 15.72%, and number 3 will be 15.64%, and number 4 will be 14.23%, and number 5 will be 15.76, and hold number 6 will be 15.70, and number 7 will be 11.88. Okay, just take note of this percentage for each hold. Then we proceed to the next. Again, you put all your cargo holds 1 to 7, and this will be your total cargo to load, which is 66,588. Okay, so you put here from 1 to 7, you put 66588. Then you multiply it by your percentage. So with this figure, you divide this by 100. Number 1, you will have 0.1107. Number 2, divide this by 100. Number 2 will be 0.172. Okay, and number 3, 15.64 divided by 100, then you will have 0.156, and so on. Multiply this percentage by your total cargo to load, and number 1, you will have 7370, and number 2 you will have 10,460, and number 3 will be 10,420, and number 4 will be 9,470, and number 5 will be 10,500, and number 6 will be 10,450, and number 6 will be, number 7 will be 7,980. Okay, by the looks of it, okay, so this is the answer. So in hold number 1, this is the capacity of cubic meter in each hold, and here's the percentage, the share percentage, which is this one, and the cargo for each hold will be this one. Then just round it up until you have the same figures. Okay, what it did here is reshuffle the numbers, meaning rounded. For example, in number 7, 7915, we just put 7900, and maintain in number 6. In number 5, he put addition, he put 10,458. This one in number 4, he made it 9,500. So it depends on how you round it up. Okay, this is how it goes. So this is the percentage loading without using the stowage factor. Okay, can be used without stowage factor. So we are loading without using the stowage factor. The other one, we will use the stowage factor. Okay, this one, number 4, field percentage method. Distribution by field percentage method. Calculate general field percentage. This guys, this one I already put it into Excel, so it can be This one cannot be used without stowage factor. So I just rewrite this one and I put into Excel. Okay. So here, which is field percentage method, exercise 4, distribute by field percentage method. Calculate general percentage. This is our stowage factor of 0.9 cubic meter of metric tons, which is this one. So this is our stowage factor, 0.09 cubic meter per metric tons. And total hold capacity is 82025. See, total hold capacity, or the sum is 82025.08. Okay. And this is the formula in field percentage. So total cargo, your total cargo, which is 66,588 metric tons, times stowage factor of this one, 0.9 cubic meter per metric tons, over the total hold capacity of 82025. Okay, then you multiply this by 100. So first we go to hold number 1. You put here the total cargo, which is 66588 times your stowage factor over your total hold capacity times 100, and your percentage for hold number 1 is 73. Percentage, field percentage will be 73.06. Okay, that will be the percentage that you're going to apply when you compute for the percentage of, or the value or weight of to be loaded in each hold. So this should be your percentage of 73%. Number 2, number 2, cargo weight. How to compute for the cargo weight to be filled in each hold? That will be hold capacity. So what is your hold capacity? For example, in number 1, your hold capacity in number 1 will be 9081.11 times the percentage, which is 70%, over your stowage factor of 0.09. Okay, so in hold number 1, what is the hold capacity of number 1 is 9081.11, what I showed you a while ago. This one. Then times your field percentage of 73 times your stowage factor of 9, and the weight that you're going to hold number 1 to load in hold number 1 is 7365. Okay, I'll explain this one later. Then in number 2, the same formula. Hold capacity is 12891.56, 12891.56 times your percentage of 73 over your stowage factor, then stowage factor, this one number 2, then hold number 2 will be 104.56. Then in number 3, hold number 3, hold capacity is 12831.48. Number 3 is 12831.48 times your percentage, fill percentage over your stretch factor, then you're going to number 3, I'm sorry, this is number 3, 10408. Okay, then hold number 4, the whole capacity of number 4 is 1167.171.47 times your fill percentage over its factor, then number 4 will be 946,467. Okay, then number 5, again, the whole capacity of number 5 times your percentage over its stretch factor, then the weight you want to load in number 5 will be 10485. Then in number 6, whole capacity is 12881.13 times your percentage over your stretch factor, then you're going to load in number 6 is 10448. And number 7, the last hold, the capacity of metric tons in number 7 is 974108 multiplied by your percentage, fill percentage over stretch factor, then this will be you're going to load in 901. When you add this cargo from 1 to 7, total cargo will be 66530, which is less of your total cargo of 66588, which is 66588. So what you are going to do from hold number 1, you make a runoff of the figures. So in number 1, you instead of 7365 you make it 7380, and number 2, from 10456 you make it 10450, and number 3, 10448 you make it 10450, and number 4 you make it 9467 to 9500, and number 5 will be 10485 you make it 10458. Okay, depending on how you want to distribute your cargo or make a runoff. In number 6, 10448 you make it 10450, and number 7, 7901 you make it 7900, a total of 66588. Okay, depends on how you round off these numbers. Okay, now going back to the figure a while ago, I think if you notice in hold number 4 the cargo is less, but in number 2 and 3 and 5 and 6 he has more cargo here, so he has more weight here and more weight here. That will be, if we have more weight on the forward and up part, that will be in hug condition. But just what I'm trying to say is, you put this value in your Loadicator and look at your shearing force, or whether or your deflection, whether it is hug or sag, and look at your what you call this deflection and your percentage. It is if it is hug or sag condition. So if the hug condition, if it is a hug condition, you better adjust your cargo. You put more cargo in the middle, and you take out cargo in the forward, put in the middle to reduce the hug. Okay, and it is sag. So take out, when it is sag, you take out cargo in your middle, put it on the lower part, take out a little bit cargo in the middle, and put it on the up part. So, but as I look from these figures, the vessel is in hug condition. When it's hug, take out some cargo here, put it in the middle, take out cargo in the lower part, put it in the middle to reduce the hug. Okay, that is how you play with the figures. Okay, so that's it, guys. So it's better that you make a draft like this to so you can easily fill up the cargoes on its hold using these formulas. Okay, so again, you can again repeat. You can make this solution by writing like this, then until you get the weight for your cargo. Okay, so that's it, guys. I hope you like this short video, and if you like, please click the like button, share, and subscribe, and please don't forget to click the notification bell. Thanks for watching.